Hi, everyone. I'm here today to talk about prompt engineering and AI security. I'm joined by Sander Schulhoff, who is the CEO of learnprompting.org, the world's first online resource for prompt engineering, and also an AI security expert. Thanks for joining us today, Sander.
Thank you, Dr. Waku. It's fantastic to be here.
Our video today will have 3 parts: introduction, prompt engineering, and jailbreaking LLMs. So part 1, introduction. So Sander, tell us a bit about yourself and how you became an AI researcher.
Yeah. So my background is in deep reinforcement learning and natural language processing, the foundational technologies behind ChatGPT and all that. But these days, my work is focused on running learnprompting.org. So I'm the CEO there, and we were the first guide on prompt engineering on the internet. And so these days, we are an AI education and research lab. So we run large scale studies on prompt engineering and prompt security. In particular, we ran the first competition on prompt injection and are about to run the largest AI red teaming competition ever.
So back in the day when you were in undergrad, which I think was only a few years ago at this point, what was it that you were working on?
Yeah, I think it was like under a year ago at this point, which is pretty crazy. But all of my research, really my research career, started out with the board game Diplomacy. Are you familiar with that one?
I am, yeah, but maybe describe it for our audience.
Sure. So it's a bit like the game Risk, where you're trying to take over the whole world and rolling dice and moving pieces around and building armies. But diplomacy is focused on just Europe, and there's no random chance in the game. It's all about talking to other players and making alliances and backstabbing people. So very much focused on communication, and for that matter, natural language. So we were building bots that were trying to deceive humans using natural language.
Do you communicate with other people through text? Like were the bots basically generating text and then interacting with humans that way?
Yeah, yeah. So they would. They would generate different types of text. So sometimes it would be straight up natural language. Sometimes they would generate this like restricted bot grammar called DADE, that we could then kind of translate into English, and so humans could easily understand that. But yes, they would be able to communicate with natural language.
And based on the game description, it sounds like the big thing is deception, right? Trying to figure out what other people's true intentions are and things like that.
Yeah, that's right. I mean, that is, I guess, kind of the core component of the game, and something that was, a big focus back then was getting these bots to be able to do that seemingly human behavior of being able to deceive people. And funnily enough, these days, that seems increasingly relevant with all of the alignment research and control research going on.
That's right. We would love it if the answer to can AIs deceive humans is actually no, right? But was there ever a concerted effort to solve diplomacy like the way there was for chess, like from DeepMind or something?
There have been efforts for many years. Most of these focused on no press diplomacy, which means no talking in natural language, which means just doing moves on the board. And theoretically, you can kind of communicate through the moves that you're executing on the board. But there were a lot of bots trained on kind of pure RL through that. And then only in the last 2, 3 years, I think we've seen natural language coming very strongly into play. And the best effort there was out of Meta, where they trained some I think it was like a BERT-based language model to basically play the game, generating messages to talk back and forth with humans and also execute moves on the board.
Are there other research projects that you were working on that you wanted to talk about?
Yeah. So another good one is called MineRL, which stands for Minecraft Reinforcement Learning, basically. And so it is a couple things. It's a Python library, but it is also a competition that was run yearly, organized by a bunch of folks from Carnegie, DeepMind, OpenAI, Microsoft, and other places. And basically, they put up a bunch of prizes and said, hey, train an agent using RL, often behavioral cloning, to solve some problem. But usually these problems were not very straightforward. So I guess they started out with things like, mine a diamond. And there's a lot of things, different pickaxes and tools and materials you need along the way there. But then the challenges started getting more abstract. And so suddenly it would be find a cave or take a picture of a waterfall. And the picture was actually executed by throwing a snowball at the waterfall. And these things are much harder to define programmatically, impossible, really. I guess at least for the waterfall part in Minecraft. And so the way that they scored these bots was to have humans watch the successful clips and decide in a kind of left right. So they'd look at two clips side by side and decide which was better. And then they produce the whole data set of preferences from that, but also use that for the scoring in the competition.
Aha, so someone had to go out and recruit a bunch of Minecraft players for research.
Yeah, yeah, that's right. Not too difficult to do, I suppose.
So even at that early stage, you were actually focusing on large contests with lots of people involved and so on. You weren't actually organizing the Mine RL contest, were you?
I was on the organizing team.
Oh, you were also on the organizing team.
Yeah,
Interesting. So that I can see how you would go from that into your projects later on.
yeah. I was probably the most junior member of the organizing team.
I sense a theme here. Do you want to tell us a bit about learn prompting?
Yeah, so actually this plays in well with diplomacy because with that kind of bot language I had mentioned, we were trying to figure out how to translate this bot language to English and vice versa. And I, somewhere along that way found a GPT-3 Text DaVinci 002 at the time, which doesn't even exist anymore. And so I was prompting that to do this translation task and produce this little internal white paper. And the research group was pretty excited about that. And I realized, like, okay, this prompt engineering, I don't even know if I called it that at the time, is pretty useful. I would really love it if there were a website out there where I could learn more about this, more about how to do this. And there wasn't. If you looked up prompt engineering, you got like a couple scattered blog posts and probably really not much at all on Google Scholar. So I pretty much started reading hundreds of papers and blog posts and putting together the first website about prompt engineering. I actually did it for English class. At the time, it was my English class project. And so I ended up, winning some writing award at Maryland, which is quite nice, but then also going very viral on the internet, which was a bit nicer.
So that's learnprompting.org. Of course, it'll be linked in the description below if anyone would like to check it out and hasn't seen it yet. So after you made the website, it went viral and it became a business, right? Because you now say you're CEO of learnprompting.org.
Yeah, that's correct. And honestly, I mean, I guess obviously when I first made it, it was just intended to be a research project, just like a fun thing that people in my lab and my friends and like my startup incubator would appreciate. I was actually in a startup incubator called Startup Shell at the time, which, by the way, if anyone listening is ever going to UMD or looking to send their kids there, is the most transformative experience one could have at the university. And so I was there, because I wanted to be building cool stuff, but not necessarily start my own business. But the success of the open source project just really gave me that opportunity.
So that's wonderful that you've been able to make a career out of that essentially, because I guess that's your full-time job now. And it's just really exciting, especially, having just come from undergrad. I think a lot of people in your position would have expected to have done a PhD first and take a lot longer about it. What are you doing under the umbrella of Learn Prompting these days, beyond just the initial web pages that you created?
Yeah, so we run three types of courses, basically. We have a bunch of asynchronous courses, video courses, kind of like Coursera, but just focused on generative AI. Then we do live courses as well that are cohort based, and we do those on AI security, prompt engineering, AGI. And then we also do bespoke workshops for different companies like OpenAI and Microsoft.
So OpenAI invites you to come teach their employees how to write prompts. Is that right?
Yeah, that's correct.
It seems like you've been very drawn into this like education space, working with learn prompting and courses and so on. Is there anything else you're doing in that area?
Yeah. So actually, we do quite a bit of research into that area, particularly on using AI to generate and assist with the generation of courses. So one thing I've been focused on recently, I've had a lot of family members wanting to learn about generative AI. And I looked at our course selection, and it was kind of too technical or not technical enough, just not quite what I wanted for them. And so I ended up going and having to find a bunch of different resources. And then I realized that I could actually use generative AI to build courses. And so what we've gone and done is created a kind of AI course generation toolkit where we can create courses on prompting a chatbot like ChatGPT, writing code in VS Code, and even generating slides with animations on them. So we can now basically have an AI do all this stuff and then do a voiceover with my voice, and then recently also have like an image of me there talking. And so now, if my aunt wants to learn Gen AI, it can be like, okay, what are you interested in? What's your job right now? What are some of your concerns? And then I'll go to my like AI course generator and say, hey, like I want this general curriculum, but kind of customize it towards these interests. And it'll do that. And it is looking really, really good. And it's something I'm personally excited about because I want to learn from these things, about lots of different topics.
It sounds like you may have just invented the field of no teacher teaching or something like that. Also, are we talking to the real Sander right now, or is this an AI?
Hard to say. Yeah, it could be either way. No, really, there's really no way of confirming that. Interestingly enough.
Given how difficult it was to enable the blurred background on your side, I don't think an AI would have been able to figure that out. So there you go.
That's fair.
Well, you have quite an interesting background coming from these like NLP projects and large scale competitions and education and using AI to automate all the things that teachers are doing. It's really cool. I'm excited to dive into your actual knowledge about some of this stuff. So let's move on to part two, prompt engineering. Can you tell us a bit about some of your academic work in terms of analyzing types of prompt engineering?
Yeah, absolutely. So, I mean, technically, everything started with learn prompting and assembling all those prompting resources. But at some point, I thought, well, I'd love to do a systematic literature review here. And I've pretty much already done one with learn prompting already. So I leveraged a lot of my knowledge from that and put together a research team of about 30 folks. So researchers from my university, UMD, as well as researchers from OpenAI, Microsoft, Google, Stanford, Princeton, and a variety of other institutions. And we spent about 9 months to a year reading through thousands of papers on prompting, using generative AI to help with the search to make sure they're relevant and put together the most comprehensive systematic literature review of prompting and prompt engineering. And it's about 80 or so pages long. Have you had a chance to look at it?
I have, but I love how nonchalantly you describe this. Like, oh yeah, I'm an undergrad student, and I put together a research team of 30 researchers from all the top universities around the world. How do you actually do that?
Yeah, that's a really good question. I think it's always good to start very small and kind of add people along the way, which is what I did to a certain extent. I think I added quite a lot of people at the beginning, but basically, I was like, okay, this can be a super cool project. It's obviously going to be a lot of work, and I knew that the lab I was at, Clip at UMD, had a lot of super smart, PhDs and researchers there. And so I was kind of planning out what this paper was going to be like and what some of the different sections might be. And I put out ads basically in the lab Slack as well as the startup shell, my startup incubator Discord, because a lot of people there were interested in AI, interested in AI research, and got back a bunch of interested folks. And we just kind of started having regular meetings. We probably had like we had a meeting a week, probably like 8 to 12 of these in-person meetings, and we at some points had like, I don't know, like 15 people in this tiny room. And over the next couple of months, it really we were able to solidify the sections of the paper that we wanted to have. And at that point, and we already had like a PI, a professor on board, and at that point, we could see, all right, like we need people with these different areas of expertise. So we started reaching out individually to different PhDs, different professors in the lab to get them involved with those sections. And they did that work, and then did a couple of case studies. There's a good bit of coding and evals being run for this paper. And at the very end of the day, that it came down to just me and a couple other people doing all like the super heavy revisions to get this thing out. And then at some point, it was back to just me because I was the only one with sufficient like all around domain knowledge to read through this entire like 85-page paper, and I must have read through it at least 10 times, which takes a really, really long time.
I can imagine. I was just working on a 60-page paper for my work, and it just takes forever to read that kind of thing. I just find this really fascinating because it was like, you hopped on this opportunity to define a website and explain to people how prompting works. And then that made you, an expert in this, such that a group of much more senior researchers was willing to follow your lead and, work on this massive survey, which probably got lots of citations at the end of the day.
Yeah, that's true.
It's quite fascinating to me. But sorry for the tangent. Did you want to talk a bit about what's actually in the paper there?
Yeah, absolutely. And yeah, as you mentioned, we have recently hit 100 citations, which is pretty exciting. It's now my most cited first author paper. I'm on some other paper that has like 420 citations, which is pretty crazy because it was recently released as well.
Congratulations. Well, you know what they say in the US, if you get about 150 citations on a paper, then that qualifies you for the the genius visa,
Oh, really?
like to become a professor. Not that you have to worry about it as an American, I assume.
Yeah, I mean that's true enough. Are you talking about like the O1?
Yes, yes. If you have a paper with 150 citations, you can get the O1 typically.
Wow, I did not know that. That's super interesting. Yeah, but yeah, in the paper itself, so okay, we had a bunch of different sections on prompting techniques. So first of all, there was the section on text-based prompting techniques, and then we had multimodal techniques. We had cross-lingual, multilingual techniques. And then we also had prompt engineering techniques. So there's a very critical difference between prompting techniques and prompt engineering techniques. Prompt engineering techniques actually, for the most part, they start with some prompt and then they iteratively optimize that prompt. Whereas prompting techniques give you some very straightforward formula to construct a prompt that you just expect to be good without any optimization steps. So a prompting technique might be like chain of thought, where you add, oh, let's think step by step to the end of a prompt to get the model to write out all of its steps. And that's just something you expect to improve the behavior. But then a prompt engineering technique might take that and kind of iteratively test it out on some data set and modify it in different ways. But anyways, probably the most important parts, really like the meat of the paper, were those text-based prompting techniques. And so there were 6 classes that we ended up deciding on. And so the kind of the simplest 2 classes were zero shot and few shot prompting techniques. In few shot prompting, it's really simple. It just means you show the AI examples of what you want it to do. An example that I often give of this is for summarization. So with all those online courses I teach, we often take the transcription and send it to Claude and say, "Hey, please summarize this for our learners." But sometimes it doesn't style it quite like I want it to, and so it'll say things like, "Oh, and then Sandra Schulhoff says this or that," and I'm like, "No, I don't want my name in there. That's like a weird way of doing it." And so what I've done is I have summarized a couple sections of different transcripts myself, and so then when I go to Claude, I say, "Hey, here's the transcript. Please summarize it. Here are a couple examples of summaries that I've done in the past that I like that you should follow." And then it's able to keep those in mind as it's doing the summary and thus do a much better, more appropriate job with the summary.
I definitely do the same thing when it comes to YouTube titles. If I'm just like, hey, what's a good title? It will give the cheesiest titles imaginable unless I give it some examples of, things that I want.
Yeah, that makes a lot of sense. And of course, few shot prompting, giving examples, is not just a good technique for these open ended tasks, but it's also a very, very good technique for things like classification, where you have some very apparent measure of accuracy. And so then you can kind of, swap your different examples around and kind of optimize them as well. So in particular, there actually within the few shot prompting section, we have kind of 6 pieces of advice that we offer for how to construct and use few shot prompts. And one of the less obvious ones and kind of concerning ones, actually, when it comes to like being able to understand and work with generative AI, is that the order in which you list your examples can heavily affect the outcome. And so there have been some papers that show on some tasks like, oh, if you swap the order of these 2 examples in the prompt, your accuracy drops to 0, or like up to 90%. So it's a really wide range, and it's often worth testing out different orders. Have you ever found that, out of curiosity?
I don't think I've experimented enough with that to really notice the difference. Just have different lists of title. If I'm doing title generation, have different lists of titles. And yeah, sometimes this list of titles doesn't do the job. I ignore it and try a different list. But it sounds like it's a good resource for people that are trying to optimize their prompts. What do you call it? The prompt engineering aspect rather than the prompting aspect, right? To like, oh, I have this thing that kind of works, or I'm at some stage of this process of building a prompt and I would like to optimize it, figure out how it works, why it works, make it better.
Yeah, and of course, yeah, just as you said, like there's, I guess as I mentioned before, there are automated prompt engineering approaches, but then there's also manual ones, which humans are doing when they're thinking through how to improve their prompt. The other thing about few shot prompting that I'll mention, just another piece of advice, is that having more examples in your prompt is often very helpful. So depending on kind of the length of the examples, if they're summaries, they might be very long, and the context window you have available, you can include more or less of them. I guess with that, I will hop on to some of these other types of prompting techniques. So the other one, the opposite of few shot prompting, basically is zero shot prompting when you don't have any examples to show. And there's a bunch of zero shot prompting techniques. This is kind of a catch-all, to be honest. But one of the most intriguing ones is called rereading, and it's pretty straightforward. Basically, you have some prompt. Maybe it's a question like, "What is the capital of South Africa?" And all rereading does is it takes that question and duplicates it. So now your prompt says, "What is the capital of South Africa? What is the capital of South Africa?" Just says it twice.
Why twice? Why twice?
Yeah, that's a good question. And I don't know. I don't think the authors of this paper know exactly either. I have some theories, but they do find empirically that it seems to help with some tasks. I will say on older models, more like GPT-3 class models, I think, and I don't think it would have much of any effect on current models. But my thought for why it helps, I think it kind of allows the model to like do kind of reasoning internal to the transformer, because with more tokens to like, I don't even know if this is the right word, but I think ameliorate.
Ameliorate, like to make better.
Now I'm looking for a word that's like distribute across. Anyways, it has more tokens to use in its internal transformer reasoning process. And based on that, I think it just kind of has more space to work internally in the transformer and thus can better solve the problems. But it's just a theory.
It's kind of like having a longer chain of thought available, right? It can go through more mini steps towards reasoning through the solution. Makes sense.
Yeah, exactly. All right. And so I guess I can go on to another set of techniques, thought induction techniques. So these are basically techniques just like chain of thought, but we just had to have some broader classification because not all thought induction techniques are chain of thought exactly. I won't get into that too much because I covered chain of thought before, but I'll just say there's a ton of these different techniques that are variants of chain of thought. Then there's decomposition-based techniques, which break problems down into sub-problems and answer all those individually before solving the main problem. Then there's self-criticism-based techniques, which propose some answer and then criticize themselves and refine their answer. and could do that iteratively to really any extent. And finally, there's ensembling techniques, which pretty much use multiple prompts to solve the same problem. And then at the end of that process, they just see what was the most common answer and select that as the final answer.
Very cool. Sounds like you had a pretty comprehensive breakdown, and sounds like I should read some of this as well.
Yeah, absolutely. We've actually seen people use this for job interviews. It's been adapted into a number of different enterprise documentations on prompting, prompt engineering, and there have been, I'd say, at least 5 different Python libraries that have spun up based on the paper.
That's amazing. It's like you're defining the fundamentals of the new field of prompt engineering.
Yeah.
So I guess if you want to brush up on prompting, you should check that out. Again, we'll link the paper in the description below. And now let's move on to part 3, jailbreaking LLMs. So this is the part that's most interesting to me personally, because I have a cybersecurity background. So I'm very excited to hear what you have to say about this, Sander.
Yeah. Security is also quite an exciting topic for me, even though I don't have any security background other than like very, very basic hacking stuff from college. But yeah, where do you want me to start when it comes to my AI security work?
So I know you were involved in HackAPrompt, which was this massive competition. Was that kind of your first foray into jailbreaking and malicious prompting and stuff? And if so, can you tell us about it?
Yeah, pretty much. So HackAPrompt was the first global competition and study on prompt injection. I saw the original posts on Twitter about prompt injection, kind of discovering it. And I thought to myself, okay, this is really great. Someone is definitely going to run a competition on it. And I thought, I'd participate or whatever. And I waited about a month. Nobody had done it. And I figured, all right, well, I could use another research project right now. I had like 2 going, but what's one more? And I was like, all right, I'm going to do this. I'm going to run a competition on it. So I started talking to some friends of mine. My friend Louis is a YouTuber, but also a PhD student at Mila. Interesting connections here. So talked to him, got some folks from Mila on board, ended up getting some people from my lab involved at the end of the project. But for the most part, it was just me and a couple Mila folks working on this. And we put together basically 10 different challenges. And I reached out to a ton of different companies to get sponsorship and got, Scale, OpenAI, Preamble, another company. They were our biggest sponsor. And they were actually the ones who had first discovered prompt injection, but internally disclosed it to OpenAI. So it was not a big public thing. And so I kind of had, everyone that I was really interested in having on board, and we ran this competition. There were like 40,000 in prizes, and we ended up collecting 600,000 malicious prompts within, I think, a month. And that was a lot of data. This is, to the best of my knowledge, the biggest open source data set on prompt injection.
It's like a human crafted data set. You got everybody to be your mechanical Turks, right?
Yeah, something like that. But I mean, it was not intended to. Well, I mean, it was a research project, but it was not a data labeling project exactly. But we did find that a lot of companies, when we open sourced the data set, used it to train and benchmark their models. Which was really quite exciting to see. There have been at least 3 citations of the work by OpenAI over the last couple months, and pretty much every AI lab, AI security company uses this to train models, guardrails, do robustness benchmarks, all sorts of things like that. So yeah, it's a super, super exciting and impactful project. Oh, and it also won best theme paper at EMNLP out of about 20,000 submissions. And according to some person at Apple that I spoke with there, I was the second undergraduate to ever win that award. So yeah, really quite exciting.
Yeah, that's a big conference too, EMNLP, and 20,000 submissions. You can tell it's a big conference. So yeah, congratulations.
Thank you.
So what did you learn from how everyone was interacting with these prompts? Were there new strategies developed during the competition, or did you do a categorization of malicious prompts the same way you did for ordinary prompts?
Yeah, good question. So a couple really core takeaways. One is that prompt-based defenses do not work. And by this, I mean, you can't say in your prompt something like, oh, if somebody puts in malicious instructions, just ignore them or don't respond or respond in a certain way. Those things don't work at all. And unfortunately, there've been a lot of research papers on these techniques. Funnily enough, even like some of the challenges that we ran in the competition, some of the different defenses, basically every challenge was a different defense. We later saw research papers that were talking about these defenses, not citing our work, obviously. And we're like, oh, this defense is, so great. And I think I reached out to some of these people. I was like, hey, and we just ran this study on this and it doesn't work at all. I don't think I ever heard a response back, but that's okay. Didn't really expect to. But yeah, in terms of a new attack, yeah. So we had a number of novel attacks. Most exciting one was something called the context overflow attack. And to understand this, you have to understand the main goal of the challenges in the competition. So generally, the goal was to trick the bot into saying the exact words, "I have been pwned." Whereas the bot had been, instructed by us, the developers, to do something else. And people realized that they could trick GPT-3 into doing this. They could trick Flan into doing this. But with ChatGPT, they had a little bit of a problem. They could trick ChatGPT into saying the phrase, but ChatGPT was so verbose that it would blather on about all the horrors of being pwned and this and that. And of course, that didn't count as a solution because we were string checking for this exact phrase and nothing else other than like spaces or line breaks, possibly. So at some point, people got so frustrated by this that they started looking at the transformer architecture itself and seeing where any potential limitations were. And so some very smart people realized that, okay, it has a context window. There's only so much stuff it can take in and output. And so they started crafting really, really long prompts, like 4,000 token long prompts, where most of the tokens were just like backslashes. And then they had some small adversarial instruction at the end of that. And then there were about 6 tokens left for the AI to respond with. And so what they were able to do, they tricked it into saying, "I have been pwned," and that was about, say 6 tokens. And then the AI would try to keep outputting text, but it hits its context window limit and just can't. And so with that, they were able to successfully complete the challenge.
So you're saying that when the context window fills up, the AI doesn't just like bump the oldest tokens out. It just is like, stop, halt. It can't do anything else.
That's exactly correct. Yeah.
Very interesting. So what has happened with the data from that contest after the fact?
Yeah. So we've seen a lot of really exciting uses here. One of the most exciting ones for me has just been helping to kind of standardize terminology and taxonomies in the space. We built a pretty comprehensive taxonomical ontology, basically a taxonomy of different attacks, 29 different attacks we saw in the competition. And then that has been used pretty widely by lots of companies doing automated red teaming, but also looking to defend against malicious prompts. We saw the dataset used to safety tune models, to benchmark models, also to build guardrails. So actually, if you go onto Hugging Face, where the HackAPrompt dataset is hosted, you can see different models that have been built using it. So that's a really exciting impact. And then I think all the citations are nice in that we've been able to affect so many works on AI red teaming down the line.
Everybody loves a great data set, and it sounds like you had an absolutely massive one. So that's definitely great work. And are you planning to run a follow-up of that competition at all?
Yeah. So we actually have this very much in the works. We are running HackAPrompt 2.0 in April 21st, and we have $500,000 in prizes this time.
More than 10x. That's pretty good.
More than 10x. Yeah. So I'm super excited about that. And this time it's going to be a whole different competition. We're talking like 5 tracks, big focus on agents, big focus on future harms, attacks against like military, generative AI integrated command and control systems, CBRN elicitation, tricking agents into reporting misinformation or writing viruses, all sorts of stuff. So that's going to be really, really big. And we're going to be, leveraging and promoting this to our whole community. partnering with YouTubers like you to get the word out, and doing a whole lot of things on kind of the media and community side. We'll have talks, we got sponsors, all sorts of fun stuff. But yeah, I'm super, super excited for this event because it will literally be the largest AI red teaming, maybe the largest AI security event ever run.
It sounds really exciting. And how long are you planning to run it for? So people can start working on it April 21st, right? And then,
Yeah, so we'll be running it from there for 2 months.
okay. So 2 months to collect all the points. Do you get a better score if you solve a problem quickly or no?
That's a good question. Probably not. We probably won't have that. Partly because in practice, it doesn't really matter how fast you are, as long as you can get to some solution. There are things like that we do care about, though. For example, length of the prompt. Shorter prompts are things that we're going to try to incentivize with special prizes. We'll also have special prizes for particularly creative solutions, maybe ones that present attacks that we've never seen before. So yeah, there'll be a lot of special prizes for things like that.
The only reason I asked is for the ACM programming competitions. They are timed, and usually the people that are really good at it would try to solve a hard problem first so that everybody else is like, that one must be easy. And they would spend all their time fashioning their head.
That's mean. Wow, that's really interesting.
Yeah, so there's a whole like psychological element when you have time in there as well. But probably fairer this way. So for the audience, of course, it will be linked in the description below. And if you don't have any experience with red teaming, I'm sure you have end of April to figure that out if you want to participate. I'm certainly excited to see more about this competition and the problems, but especially the solutions that people come up with. I think it'd be really fascinating. Maybe we can finish off here by just talking about, any projects that you have that are ongoing or on the horizon, things that you would like to do, anything like that.
Yeah, great question. Well, I guess in addition to being the CEO of Learn Prompting and running HackAPrompt as well, I consider myself to be something of an independent researcher. So right now, kind of related to work, kind of not, pursuing a couple different research papers. So one, we have a research team working on HackAPrompt. We're spinning up another literature review, but this time just about different attacks, defenses, and harms in Gen AI security. So very much focused on prompt injection and jailbreaking. And then I'm also working on a paper that is kind of analyzing attack success rates and the impact of nondeterminism on those scores and how we can potentially leverage the information that nondeterminism presents to improve different attacks. And then finally, a paper looking at guardrails and kind of trying to see whether guardrails are really a good solution for detecting prompt injection and jailbreaking. And in particular, they're looking at basically the intelligence gap between guardrails, which are usually smaller LLM-based models, and the bigger main models that they're designed to protect. Because there's some attacks that kind of just go over the heads of guardrails. They don't even understand them as potentially being attacks, and then get to the main model, and the model's like, oh, I guess I'll just follow this.
Yeah, when they released GPT-4 and they were like, oh yeah, we're using guardrails, we're using GPT-3 as guardrails. I mean, it makes sense because it's expensive to run GPT-4. You don't really want to use it for the guardrail as well. But it's bad because GPT-4 is more powerful. It can easily do things that the guardrail doesn't understand. So yeah, it sounds like an interesting approach.
And I just saw a post from Pliny today that was saying, as new models have come out, it's actually gotten easier to attack them because the attack space, which is basically their minds, right, is expanding.
That's right. You actually have a willing collaborator, which is the model on the inside, right? So like as it gets smarter, your job gets easier. So I guess it'd be interesting to see how AI security evolves in the future because right now it's pretty easy to jailbreak things. Well, thank you very much, Sander, for joining us today.
Thank you very much.
And if you're interested in anything we mentioned in the video, we will try to have all the links in the description, especially for the HackAPrompt 2.0, which is beginning on April 21st. So mark your calendars. And if you liked this video, check out this video I made a while ago now about the transformer architecture. It's a little more technical than this video, but I think you'll like it. Well, that's all we have for today. Thank you very much for watching. Bye.